Now remember, rational expression is just a fancy word for fraction. So what we'll be doing in this section is multiplying and dividing some pretty fancy fractions. Let's begin. We're going to multiply here this first fraction, 2y squared minus 6y minus 8, all over y squared minus y minus 2 times y squared minus 5y plus 6 over 2y squared minus 4y minus 6. Now I know you know at this point that the only way we can multiply these fractions is to multiply the numerators and denominators. Well, we don't want to multiply them in this form because that would be way too much work. So what we're going to try to do is write them in factored form and divide out any common factors possible. So here we go. Let's look at our first numerator. Always remember, when factoring, look for the GCF if possible. 2y squared, 6y, 8. I see a greatest common factor of 2. That leaves me with a y squared minus 3y minus 4 over my denominator here does not have a GCF. It is a trinomial, leading coefficient 1. I'm going to factor by the method of the numbers game, which is, those are y. I'm looking for two numbers that have a product of negative 2, but have a sum of negative 1. That's not too bad. How about negative 2 and positive 1? Product, negative 2, sum, negative 1. As you're working through these types of problems, you need to work very cautiously because one slip of the sign or one sign error and the whole thing's wrong. So please be careful as you work. Times, in our numerator in our second fraction, let's go ahead and we can see that the leading coefficient's 1, so it's more or less easily factorable. We have y and y. We're looking for two numbers that have a product of 6 but a sum of negative 5. Well, I think 3 and 2 will do the trick, both negative to get that positive product and negative sum. Again, take that extra 3 seconds it does to check to make sure that your signs and numbers are all correct. Now let's look here on the bottom. In our denominator, I notice that we have a greatest common factor, again of 2, as we did in the numerator of our first fraction. So that leaves me y squared minus 2y minus 3. Now, we want to make sure that we're in completely factored form before we start dividing out common factors. So I see that I can still do a little bit of work right here with these two. So I'm going to continue, and I'm going to factor that first numerator here into, now it's an easy factoring problem, y and y because the leading coefficient is 1, product negative 4, sum negative 3. Well, how about negative 4 and positive 1? And again, take the time to check. Negative 4, negative 3. They add to negative 3, they have a product of negative 4. That does work. Now, since our denominator is already in factored form, we'll just recopy it as y minus 2 and y plus 1 times, our numerator is in nicely factored form, y minus 3 and y minus 2. We have just a little bit of work to do right here, and that is to factor our second denominator. Again, leading coefficient 1 makes it easy to factor. Product negative 3, sum negative 2. How about negative 3 and positive 1? Again, check. Product negative 3, sum negative 2, and that works. Now that we did all this work, we're ready for the fun. And that is, we get to divide out those common factors. So here we go. What do we have here? We have a y minus 2 and a y minus 2 over here. We have a y plus 1 and a y plus 1. I see a y minus 3 and a y minus 3. Oh, and also we have a 2 with a 2 there. What do we have left? A y minus 4 and a y plus 1. They're not the same. So that is it. All of this reduces to y minus 4, y plus 1, And please, please, do not be tempted to divide out those y's. Again, I'll say it, these are differences in sums. They are not products, so we cannot divide them out as we did in this previous step here. So in this long problem, what did we do? We factored everything, divided out common factors, and came down to this final solution here. This is multiplication of rational expressions. Now, how would we like to divide rational expressions? We know that the only difference between multiplication and division of fractions is that when we divide, we're going to multiply by the reciprocal of that second fraction. So let's look at another problem. This time, we're going to divide the following. We're going to divide x squared plus 5x plus 6 over this x squared plus 8x. We're going to divide that by our second fraction, 2x squared plus 5x plus 2, all over 2x squared plus x. Now again, the difference here is we're doing division, but remember, the division is just multiplying by the reciprocal of that second fraction. Are you ready to begin? The steps are basically the same. We're going to have to look at each numerator and denominator and write them in factored form. So here we go. X squared plus 5x plus 6. Again, at least it's a, quote, easy kind of factoring. Product 6, sum 5. How about 3 and 2? Again, take that extra time. Check to make sure that you're correct. 2 times 3, 6. 2 plus 3, 5. I can't emphasize enough how easy it is to make a small mistake somewhere in this problem, and then the whole problem is wrong, and that's no fun. So here we go. Greatest common factor, x. So we write it as x times x plus 8. So far, so good. Now don't forget this part. This becomes multiply, and now this denominator becomes our numerator. The numerator becomes our denominator. So what we're going to do here, remember this is going upstairs. So we're going to factor this and write it up in the numerator. So these guys, to remind yourself, if you want, you can put that little arrow to remind yourself to switch places there. So this is going upstairs, greatest common factor, x. And we have here a 2x plus 1. So far, so good. I know these are exhausting, but you have to be really, really careful. Last numerator that's going to become our denominator that we have to factor. So here we go. Now this is a little bit tougher because the leading coefficient is not 1. It happens to be 2. But again, I like to use the method of trial and error when I'm doing especially these long problems, because if I didn't, it would take me a long time. But feel comfortable that if you cannot factor using the trial and method error, off to the side, on the margin of your paper, you might want to do the grouping method or something off to the side, and then put the final factorization here so it does not make your problem way too long. Okay, so we have 2x and x. Now we're going to have the 2 product. Now if I put my 2 here and my 1 here, that will create 2 times 2 plus 1 to get me the 5 that I wanted. And again, let's check. 2x squared, positive 2, everything works. Okay, now did I switch them? Yes, this came to the denominator, this went to the numerator. As I said, you can't be too careful. These are very, very complex problems. Okay, now we did all the hard work. Now we're at the fun part. We get to reduce those common factors. So here we go. What do we see? Well, I see a 2x plus 1. Those divide out. I see an x plus 2. Those divide out. I have an x here and an x there. Isn't that part fun? That's my favorite part. It feels like I'm cleaning my house or something. Okay, so what do I have left in my numerator? I've got x plus 3 all over what's left in my denominator, x plus 8. And I know I've said this a million times, but it's so important. Do not be tempted to divide out those x's because we have sums here, not products. It would be so sad if you did all this work and then at the very end divided out those x's and just ended up with 3 over 8 or something like that. So please, please be very, very careful. Again, the only difference between multiplication and division is the fact that We have to multiply by the reciprocal. Other than that, all the procedure is basically the same. Let's divide some more rational expressions. Here we're going to divide x plus 3 over x minus 3 divided by 9 minus x squared all over 1. Now remember, the key to dividing these rational expressions is we want to rewrite each numerator and denominator in factored form. Well, the first fraction looks like it's in fine form, so we'll leave it as x plus 3 over x minus 3. Now remember, dividing fractions is the same as multiplying by the reciprocal of the second fraction. So that means that this one is going to flip over. The 1 becomes our numerator, and before we rewrite our new denominator, let's look and see what we have. We have 9 minus x squared. Does that ring a bell in your mind? We've got perfect squares, a minus sign. We have the difference of two perfect squares. So this factors into 3 plus x and 3 minus x. Now we get the fun part of dividing out those common factors. Now, here we have x plus 3 in the numerator, and we have 3 plus x in the denominator. Remember, addition is commutative. So in other words, 2 plus 3 is the same as 3 plus 2. So x plus 3 is the same as 3 plus x. So I can divide out those common factors. Now what do I have left? Well, in the numerator I have 1. In the denominator I have x minus 3 times 3 minus x. Nothing else to divide? That pretty much does it for this problem. Just keep in mind the following, that when you're dividing these rational expressions, dividing is multiplying by the reciprocal of the second fraction. Make sure that you factor all denominators and numerators as completely as possible, and then have fun with dividing out those common factors.